started already. Is this thing on? It is, right, good. So my background, although I do a lot of IoT in my day job, my background is really in integration. So I thought many times ago that I'd do a presentation about why integration is important in the world of IoT. So to start with, what IoT isn't. IoT isn't devices. Controversial, I know. IoT isn't a soldering desk, right? Or any number of other devices. I mean, if you can solder stuff to things, that's fantastic. I love you forever. But you're not creating an IoT solution. You're creating a device, right? The Internet of Things, by its very nature, is misleading. I'm going to put that out there as a contentious phrase. Internet of Things is misleading, because it's not just about the things. So what IoT is it's really about the data, okay? Because we all hear about big data, 3 Vs, 5 Vs, 7 Vs. I've actually heard of 42 Vs for the velocity and so on and so forth. But really it's about sensors, obviously. It is about things. You have to have things to have data. There's gateways, edge devices. It's about connectivity, LoRaWAN, narrowband, whatever. Doesn't really matter what it is, 5G. Data storage and engineering, so you have to store the data, and as we get into larger scale devices, or larger numbers of devices, that storage problem becomes even harder. You have to move the data. You have to clean the data. This is all part of an IoT problem. Depending on what you need to do, you may apply some learning across it. You may have some AIs as well. You may have all manner of things, right? The point really is that nobody goes to their CIO and goes, can I have some IoT, please? Because what they do is they say, I need an outcome. That outcome may be optimizing my mining circuit. That outcome may be autonomous driving. But the key thing there is it's not about the things. So let's talk about this thing called an IoT value chain, because really you don't have an IoT solution, I would contend, unless you have pretty much all of these things, right? So obviously you have sensors, devices, and so on and so forth. Somehow you've got to get the data off of those devices to somewhere else. You'll store it somewhere, as I mentioned. There'll be some analytics and there'll be some action. Now that action could be as simple as a dashboard, an operational dashboard that tells you something's gone wrong, or it could be some fully autonomous system, changing the throat level of a mining circuit, for instance, of a primary crusher. All those things are really kind of necessary to have an IoT solution. And the key thing about that really is that in order to get anywhere along that journey, integration is important, right? Because you have to move data from one place to another place. That requires integration. And as you can see from the various blocks that I said, it requires integration pretty much everywhere, right? So that's my contention, and that's what I'm going to talk about today. So the key thing about that is, anybody been a sort of large-scale integration person in the past? Message queuing, all that sort of stuff, right? Yeah, all that good stuff. In the world of IoT, I mean, we talk about big data a lot. Big data is about large volumes, obviously, velocity, and so on and so forth. We tend to store that somewhere, and we process it with machine learning. But there's a lot of other paths through an IoT solution that don't require that kind of level of rigor. Things like alerts, things like status updates, all that sort of stuff. They may need to happen in a different path. So that actually means that all the stuff that you learned about integration patterns, and has anybody read Enterprise Integration Patterns? The book? Yeah? You got the book? Or did you go to the website? Website or book? Because if you got the book, then you're a real fanboy, right? So that's the most important thing. So great book, average website, but all the sort of stuff that you learn in a standard integration messaging patterns, all those patterns that you've learned for years and years and years, are still directly applicable right now in the world of IoT. So everybody gets sold on the story of big data, but really and truly, you also need integration in order to get a good end-to-end story around IoT. I'm out of time, good. So because we've spoken about AWS and about Google, and there's a third cloud provider there, I thought I'd show this slide. Because Microsoft apparently also does IoT. So the key part here really is that there are lots of moving parts to a proper end-to-end IoT solution. Just re-emphasizing that point. It's not just about the devices. But this is a serverless conference and a cloud-native conference, so why would I just talk about that sort of thing? So I thought I'd run through there we go. I thought I'd run through the sort of things that are available to us in our toolkit inside Azure. I'll let you choose which way you want to say it. IoT Hub is the central point for an onboarding IoT solution inside Azure, right? So It's got a device registry, it supports provisioning of large volumes of devices, all the security is applied there as well, and it's got full lifecycle management of your devices. So how do you get data into it? Obviously, devices, right? It's not terribly hard. They send telemetry, job's good, D2C, device to cloud. It also supports large-scale uploads. So you can imagine that, say, on the edge, where you're taking lots and lots of data, sometimes you're connected, sometimes you're not connected. Maybe you want to store that data up, zip it up, and then upload it in one go for more efficiency. Yep, there we go. So this is where the cool stuff comes in. Well, I think it's cool. Message routing. So you've heard me talk about the fact that telemetry tends to have a fairly standard path. You go through, you process the data, and so on and so forth. If you've got things like alerts, you've got things like statuses, and so on and so forth, you can pick up information in those messages and direct them to somewhere else. This is where all the serverless cloud stuff comes in, right? So here we've got table storage. That's just in Azure Storage. We've got event grid. So the event grid is essentially a, do I use the word infinite? No, let's not use the word infinite. A very, very scalable event architecture, event fabric, essentially. So the difference between that and a normal message is an event tells you something has happened and gives you context to get back to the thing that happened. It doesn't contain the message, right? So you still have to process that event. Next one down, Event Hub. Now, Event Hub is a large-scale stream processing pipeline. IoT Hub actually runs on top of Event Hub, but supports bidirectional communication towards your devices, whereas Event Hub doesn't. And the last one is called Service Bus. Now, Service Bus is one of the oldest, in fact, I remember it from very, very many, many years ago, probably 10 years ago now, one of the oldest services on what in those days wasn't even called Azure. And in those days, it was called the Internet Service Bus. But that supports queuing. That supports the publish and subscribe view of the world that Megan spoke about earlier on, right? So the idea of having a message come in and then having it fan out to many things. That's called topics and subscriptions in terms of Service Bus. All of those things are serverless. You essentially wire them up and you use them. There's no code involved in that. I won't talk about time series insights. This is a different talk as well, so I'm just getting through this. Digital twins. The idea behind a digital twin is to provide a virtual view of a physical thing. So you can imagine from a mine perspective, you may have 75,000 sensors, but you may want to roll all those up to, say, a specific mining circuit. I'm saying mining because BHP's on there as well. Yeah, so you've got to be fair, haven't you? So you may go all the way up to a mine, but with a digital twin, it allows you to simulate that process because it's a physical it's the physical view the virtual view of your physical asset. You can't really very easily simulate a physical mine. Well, you can, but you have to shut the thing down, and yeah, miners don't like that. So if you can do that inside a virtual environment, so much the better. The digital twin also supports some of those off-ramps to serverless tech. But that's just getting stuff into things. You still need to consume those things, right? So at the moment, all we've got is things going into pipelines, and we don't have anything to consume them. And that's where these things come in, right? So we have top there, logic apps. I'm going to use this word a lot because it's serverless. Serverless workflow and functions. That's serverless compute. Functions, think of the same as AWS Lambda. I won't mention anything beyond that. But the key point there is all of these things are just part of a standard toolkit for anybody who does integration. On the way back, I mentioned that IoT Hub is bidirectional, so it can send messages back out to the devices. So you need a mechanism, a path for doing that. And something like Azure Functions is a great example of where you can do that. Small, low code, just a few lines of code essentially, same as Lambda, which allows you to enact something. The inbound data needs to be processed. So again, some stuff over the left-hand side there. Event Hub again is there. On the outbound, again, very similar, right? So here we've got something that can support large-scale ingestion and processing of data, bound to a SQL-type language, so you can select things out of the inbound telemetry. You can run anomaly detection. You can run different functions, user-defined functions in these things, right? So again, serverless, scales as you need it to scale, and as you're prepared to pay for it, by the way. Outbound, some of those things you've already seen. That one in the middle, on the right-hand side there, is serverless database. You see, serverless all the things, right? It's great, isn't it? So that's Cosmos DB, which is a multimodal database written inside Azure, right? So supports Graph API, supports Gremlin, supports Mongo, Cassandra, SQL, all those sorts of things, right? So what's the next slide? There we are. Databricks. So whilst I wasn't going to mention big data compute, I think it's worthwhile just mentioning something that can absolutely do that. So again, Databricks, it's just an engine that runs on Azure, also runs on AWS as it happens, that supports processing vast quantities of data in an efficient way. You can write a notebook that processes it using Python and so on and so forth, and outsquirts a lot of data. And again, it's all serverless. Let's build this out because time is running on. Key part here, again, Event Hub, Kafka as well. So you can have a Kafka on-ramp for Databricks. Worth noting, and I wouldn't be doing my job if I didn't do, that Event Hub actually supports Kafka as an inbound data stream. So you can actually just point, if you've got an on-prem Kafka server, you can actually just point that to an Event Hub and it will just consume the data. Cold path data, again, from Cosmos DB. It's the theme working up here, right? So, and then outbound. And then the final one is Cosmos DB, which I did want to just touch on. It's not as nice a slide because somebody else built this one. So it's probably nicer, actually. Key point here is I've mentioned Event Grid, which is essentially a vast event architecture for processing large volumes of events. Cosmos DB has a similar thing. It's more of a log than anything else, but it's called the change feed. So every time you write something into Cosmos DB, it emits an event. And you can work on that. So Azure Functions has a binding that binds straight to the change feed, and you can start processing that as you need to. So, not surprisingly, where would you use it? Same place as you'd use everything else. Just because this is an IoT solution doesn't change the impact of integration. I often think of integration as, so we all know non-functional requirements, security, auditing, logging, all the good things, right? We all know they get left until the last minute because although they're very, very important cross-cutting concerns, nobody cares. We all know that's true. Integration has always, for me, been the same thing. It's one of the most important parts of a solution because you can't solve large parts of the solution unless you do it. But it always seems to be one of those things that's left right until the last minute. Now, we had a conversation earlier on about how you work in agile teams. The key part to doing all of this sort of stuff is understanding the contracts between the things that are integrating. Because if you can do that, you can have teams work in isolation. But good example there, asynchronous messaging, load leveling, again, all the usual good stuff. Machine-to-machine interaction, quite often missed out in terms of general sort of approaches to things. Status updates and alerts I've mentioned. Firmware updates. So if you've got a vast fleet of devices, you may want to update them all at once. Well, Azure IoT Hub allows you to query the devices, update a flag, and then that flag can make all of those devices download a bin file or whatever it is, and so on and so forth. Command and control, so if you want to send stuff back to the devices. So we are 6 minutes. So that means that I can go to my demo now, so that's good. So where are we? Code. Oh, hang on. Let me just get out of that first. Every time I do that, the keyboard freezes. Fantastic. Right. So that code. So Azure IoT Hub comes with a bunch of SDKs in lots of languages, Node.js, Java, C#, as you see here, Python, a few others. And the idea behind this is it actually wraps a bunch of C code behind it. So if you've got a really, really lightweight device, you can run it as C and just run it as embedded C, and it all still works. But this is just kind of a layer on top of it. So I won't go too heavily into the code here because I'm in danger of running out of time. But the key part up here is you can see it says client, device, client, create from connection string. You'll notice that the key is off the side of the screen there, so as you can't start sending stuff to my devices. No, I'm joking. So essentially what I'm doing, I'm connecting from my device. This is just a console app simulating a device. Connecting from my device. I'm then getting a twin, so I'll show you what that is when I go to the portal. I'm setting up a couple of methods so as I can basically send data back to the device. And then I'm doing a bunch of other things and sending data, obviously, from a telemetry perspective, sending data, so I send that every now and again, uploading files. We'll see what this stuff does, but the key point here really is that this is not terribly difficult code to write. I wrote this. please don't judge my code. There is no exception handling. I'm an architect. I draw boxes and lines. So it's a very key point. But none of this is particularly tricky, right? So where the smarts is actually in the portal here. So I've got lots of windows open just to make it easier for me to navigate. But essentially, this is the control plane for Azure IoT Hub. And in here, we can go down here. Oh, hang on. That's where it's easier with a mouse. I can go to my devices, and this is that device registry that I was talking about. Okay, and I'll talk about some more stuff in here in a second. Because the other thing that I want to call out, really, is where it says message routing. Come on, phone, you can do it. So essentially what I've set up is I've set up these routes. So if something is message type status, it goes to that endpoint. And I can create these endpoints really simply. So if I go to custom endpoints, the reason I'm showing that is not to bore you. It's to show you how easy this stuff is, right? Add, I can do a service bus queue. And you can see it's wiring all this stuff up for me, right? So IoT queue. Okay, right, queue. So I can choose my namespace. So I'm not typing anything in. All this is being wired up. The power of platform services, right? It's fantastic. Don't do this stuff yourself. Of course, you can if you really want to. So Microsoft has a version of automation called ARM templates. You can put all this and dehydrate it into an ARM template, and then you can just click a button, and all this will be wired up for you if you want some kind of CI/CD pipeline. But I won't just do that right now. Yes, quit. The idea behind it is you set these things up, and you pick up properties in the message, or you pick up data inside a message, and as a result of that, you can route those messages to endpoints that you can then process with something else. That was a long, breathless march, wasn't it? So I'm going to go into here. First off, I'm going to kick off my code, because I do say in my intro that this was an end-to-end solution, so it'd be a bit remiss of me if I didn't show it. 3 minutes left. So we can see it's doing stuff, and you can see it's sending a message there. So this here, that's actually a status, right? So in a second, there you go, it sent a message. Humidity and air quality, you'll have to take my word for it that that's what that says. If I go to, so the key point here is you'll notice that it's staying the same, right? If I go to my device, which is device 1, so the key thing about an IoT solution is you need that bidirectionality, 2 minutes. I have to hurry up. You need bidirectionality, so I can go in here and I can update a property on my device. This is called a device twin, which allows you to have disconnected comms with your device. So if I change this vary to true, spell true right, because there is no error handling. Save. Then when we go back to the code here, device twin desired property updated, and we can now see the data's varying. So I've just called from the cloud. Remind me about the Azure story, by the way. I've just called from the cloud down to my machine here, and it started updating, right? So that's now sending through a bunch of data. If we go back here, stream analytics. So this is the thing that I mentioned before around being able to process large volumes of data, stream processing. So again, similar thing. I can come into here. The other one was running, so I can't do anything with that. I can come in here, I can add, and I can just choose something. Again, I'm not wiring things up. I don't have to upload a piece of JSON, although I can do that if I really want. But I can do all this all through the portal, right? So click ops, I think somebody said earlier on. So that's great, fantastic. And you can see we have a very pretty basic standard piece of SQL over the side here. I won't dwell on that because we've already got some stuff running. So this is talking now more about the workflow. So this is a Logic app. So hopefully I clicked that. Did I? Did click it? Right. 49 seconds, right. So I've got a bunch of these, but essentially what these are doing is saying, okay, well, parse some JSON and post a message to Slack. So we go up to Slack here. Hopefully we can see we're getting some alerts. We are, fantastic. What I can also do in Slack, we all know about slash commands in Slack, right? I can say, I want to reset that device. So I'm going to call it device 1. So imagine that this could be an automation circuit. This will fail, and it will fail because, so it failed, except it didn't, because we go back to here, reset device was called. That failed when it came back because it used an Azure function, and by default, Azure functions shut down when you're not using them. There is a premium plan SKU which keeps them up all the time, But so if I issued that device, that request again, it would go straight through. So I think we're just about done, because I could show you some more stuff here, but come and grab me afterwards. A bunch of other things that are all serverless, so we'll go back to the deck, because that's now 0. It definitely says 0, and I don't want to invoke the ire of anybody who wants to ask me questions. So here we go. Right, done. So the key point really is that whilst we think about IoT as things, that's what the T means after all, to create an IoT solution, you're actually touching every part of the application stack, whether that's a web front end, reports, whatever, because it's actually about processing the data and movement of data and everything else, as it is anything else. Serverless integration and data storage, particularly in the world of IoT, is front and center of all of this, which is why this talk is called IoT as an integration challenge, after all, of course. And the last point there, again, call out to the third cloud. Azure Integration Services enable a full end-to-end solution. So it's a very, very key point. And it is just stitching those things together. But what, of course, that does mean is that anybody who's been an integration person and who's now sort of transitioning into the world of IoT means you can still be a serverless superhero. Right. Now, I'm aware that this is DC and not Marvel, so I apologize for that as much as I possibly can. And with that, I'm done. So, 1 minute over.